Hey guys, welcome back to Explore Electronics Plus. In this video, let us try to cover System Verilog from beginner to advanced level in one shot. The very first thing is Introduction to System Verilog. What is System Verilog? System Verilog is an extension of Verilog. It is designed for RTL design and also for verification. System Verilog used in ASIC and also in FPGA designs, for designing and also for verification, and it will allow us to do the functional coverage as well. Then the question is, why System Verilog over Verilog? System Verilog will be having improved data types and also structures. For example, logic and enum type. And the very important feature in System Verilog is it supports OOPS functionality, object-oriented programming. This will be helpful in writing the advanced test benches to check the functional correctness of the design, and also allow us to use assertions and coverages for functional verification. If you look at the key differences between Verilog and System Verilog, the data types what we have in Verilog are limited: reg, wire, integer and real type. In System Verilog we have logic, bit, byte, int, integer, struct as well. And also it will not support a OOPS functionality, and System Verilog support all the OOPS functionalities like support classes, inheritance, polymorphism, encapsulation, like that. And arrays are static in nature in Verilog. System Verilog we have dynamic arrays, associative arrays and queues, which are very much important in writing the test benches. And assertion support is not there in Verilog. We have support of assertions in System Verilog. Verification in Verilog is manually writing the test bench, and in System Verilog we can use an automated method called universal verification methodology that will allow us to write all the different aspects in System Verilog test bench with reusable modules. This is the quick differences between Verilog and System Verilog. Let us look at the data types. Verilog has 4-state data types, and System Verilog added many 2-state data types with that. In 4-state data types, we have values 0, 1, x and z, and 2-state data types in the sense it will take only 0 and 1. It will not take x and z values. It will improve some simulation performance in verification. You can see with wire, reg, integer, time and real, we have additionally logic, bit, byte, short int, long int, s type, that is short time, and also short real. All these are 2-state data types, and short time and logic are 4-state data types. We have a logic data type here. This will allow us to use in place of wire and register. It will support all the functionality of wire and register in logic data type. So let us quickly look at the differences between bit and byte. In System Verilog we have these two data types. If it represented as a 7 down to 0 bit and a byte, it is not same. You can see here bit type will be a 2-state data type and it is unsigned. Byte type is a 2-state data type, it is signed type. It means if you represent any variable as a bit type, 7 down to 0 my bit vector, it carries 8-bit value. If you represent it as byte, this also carries 8 bits, but it is a signed type. If you see the example over here, my bit vector 7 down to 0, it is a bit type. My byte value is a byte type. If you assign a same value like this, 10101010 for the both variables, the bit type variable will take the value as 170, but my byte value is minus 86. Why? Because it is a byte type. The value what we have written over here will be taken as a signed value. Since we have 1 not MSB, this will be represented as a negative number.
If you want to become a pro Python developer without having any prior knowledge on the subject, then join our 30-day Python using AI bootcamp. We are going to teach you Python from scratch to advanced, which includes how to include AI in your Python. Number 1, code in Python 10 times faster. Number 2, debug any code in under 10 minutes. And number 3, perhaps the most intriguing, creating apps from Python in a matter of hours. All of this is possible only when you integrate AI in Python. And the best part, you can get access to this 30-day bootcamp at just 199 rupees. Python developers who know the trick of the trade, which is including AI in their coding, are getting recruited in the top MNCs of the world. Meta, Google, Amazon, and many more, and at lucrative packages like 15 LPA, 18 LPA, 25 LPA, and much more. What are you waiting for? Click the link below and join our Python using AI bootcamp at just 199 rupees. Hurry, seats are limited.
42 lakhs per annum.
Wow, 42 lakhs, that's your salary?
Yes.
And what do you do?
I'm an AI tools and chat GPT expert.
All right, and what degree did you pursue to become that?
Well, honestly, I didn't need to do any degree for it.
What?
Nor did I spend lakhs of rupees on any expensive programs.
So if someone wants to master all these AI tools and chat GPT and earn 42 lakhs per annum just like you, how do they do it?
They can simply attend B10X 3 hours AI tools and chat GPT workshop, which is conducted by IITians. Here you will learn to create any kind of presentations with AI tools, do any kind of IT work under 10 minutes, learn and apply over 100 plus Excel formulas without even memorizing any one of them, and automate up to 95% of your work with just AI tools.
Wow, all of this in just 3 hours?
Yes, and you get to attend this workshop at just 9 rupees. So if anyone wants to learn AI tools and chat GPT, they should definitely attend this workshop. But hurry, limited seats only.
Then comes enumeration data type. Enumeration data type is a set of integrals named constants. Means we have a constant representation which carries the integer values by its own. Suppose if you see the example here, enum, within the flower braces we have red, yellow, green, and the name is given as traffic signal. Here by default red will take a value 0, yellow will take value 1, and green will take value 2. Whenever you use red in your code, it will take a value as 0 by default. Then yellow will be 1, green will be 2. Similarly, if you want to represent these red, yellow, green to a particular data type, you can put a data type over here. Enum, logic type. 1 down to 0 is the size of my variables. Red, green, blue will take 0, 0. Green will take 0, 1. Blue will take 1, 0 now. And the name of this is color. Now, we can also assign user defined values over here. Red can be 0. Green is not assigned. Green will automatically increment it to 1. Blue is assigned with 4. Yellow is the next variable. It will be automatically take 5. White is 10. Black will take 11. By default, it will start with 0 like this, or else for a particular variable, if you want to assign an integer value, we can assign like this. And also we can use enum type with user defined types. You can see type def can be used with this. Type def enum, red, green, blue, color underscore t. Now color underscore t is a enum type. You can use color underscore t and we can define the other type, other variable as my color. Now we can access red, green, blue through my color as well. Let us see the example for that. Module enum case example. Here we have a enum definition, type def enum, idle, running, stopped. So as we know, idle will be taken as 0, running will be having a value 1, stopped will be having a value 2. It is state underscore t. Now we are declaring the current state with a enum type. State t, current state. Now current state will be used throughout the program or throughout the code. It will be a enum type. You can see under initial begin, we have different states here. Current state is equal to idle. It means current state is 0. Now we have different cases of current state. Which are all the cases? Idle case, running case, stopped case. In an idle case, there is some functionality written. Running has some functionality. Stopped has some functionality. So here the thing is, there are different values we can have for current state as 0, 1 and 2. That will be declared with a enum type and it will allow us to use idle, running, stopped names of the variables as well. This will be directly taken as 0, 1, 2 different cases for the current state. Then comes arrays in System Verilog. A very important concept of System Verilog is arrays. Arrays will support static arrays and also dynamic arrays. Verilog support static arrays. Let us look at static arrays first. In static arrays, again we have packed array and unpacked array. Packed array are just like vectors. We can have bit level operations. Unpacked arrays in the sense, these are having multiple elements. It will be used for representation of a memory. Here also we can access bit level and also we can access different elements. Now let us look at the packed array first. The name packed array or the term packed array is used to refer the dimensions of the array what we write will be declared before the data identifier name. It means here we will be writing a data type first, then the width of that array, then the name of the array. Before the name of the array, we have a size representation. It is like bit 7 down to 0 temp variable. So this temp var will be taking, it is capable of taking 8-bit values now. So 7 down to 0 is the size of this assigned before the name. So here it is just like a 8-bit vector. Similarly 15 down to 0 data and 0:1023 is the size of ABC. It is capable of taking 1024 bit. So packed arrays are continuous in memory. It means all the bits are stored in a single block without any gaps. Let us look at the representation now. So if you have a same example bit 7 down to 0 temp var, it is taking 8 bits like this. Here it will be having one row and 8 bits with one element. And similarly, if we represent a two-dimensional case, 1 down to 0, then 7 down to 0. It is just like two elements of the array, which are one after the other. You can see this is an 8-bit, this is also an 8-bit. But this is the 0th element, this is the first element. We can combiningly, we are packingly representing that. Similarly, if we have three such elements, we can represent it as 2 down to 0, then 3 down to 0. This first value will be representing such number of packs we have, and 3 down to 0 representing each and every one will be having 4 bits. This is the way we can represent a packed array. You can also see one more example here, bit 2 down to 0, 3 down to 0 array. This is number of such 4-bit values array can take. So you can allocate a value like this within the flower braces 2, 4 and 12. 2 will go to the second element, we can say. This 4 will go to the first element and 12 will go to the 0th element. So this is in a single row. You can see 3 4-bit values are packed together. If you want to access a particular bit over here, first we need to give the particular element value or the location, and then the next value should be a bit number. If you see array of 2 then 1, array of 2 in the sense it will pick this first 2 and then 1 in the sense this is 0th element, this is first element, this is second element, this is third bit, so it will take this. So 2 and then 1 give us 1. Array of 0 and then 1, 0 is this, it will pick this first, and 1 in the sense this is a first bit, it will give 0 value. This is how we can define and also allocate a value and access the bits like this. Then unpacked arrays. Unpacked arrays in the sense dimensions are declared after the data identifier name. So we have a data type int and a name of the array is array. Here you can see the size is represented after the name is written. So here it is a compact declaration 6 with a verbose declaration with MSB, LSB representation. You can represent like this. So this will be having 6 rows and 1 column. You can see the row numbers here 0, 1, 2, 3, 4, 5, and since it is a int type, it will be taking 32-bit in each and every locations, and it will be having 1 column. So these 6 rows can take 32-bit, 32-bit, 32-bit in all the elements, and you can access particular element as well through that particular row number. You can see we have a 2-dimensional array as well. In the 2-dimensional, we will be representing the column number also. The very first value will be a row number, the next value will be a column number. Suppose if we want to have 6 rows and 2 columns, we will be written as 6 then 2. And also while accessing the value of this particular element, we need to give the row number as 2 and then we need to give the column number as this is 0, this is 1. We need to give it as 2 and then 0, it will pick this particular 32-bit element. So if you see row 0, row 1, row 2 till row 5, and also we have a column representation like this. So this particular location will be accessed with array of 2 and then 0. And also we have a 3-dimensional arrays. 3-dimensional arrays with row and column we will be having layered information also. This is layer 0 and layer 1. We have a same 2-dimensional array for a layer 0. We have one more 2-dimensional array in layer 1. So to access or declare that, first value will be a layer, then the next value will be row, next value will be a column. You can see here the first value is a layer, second value is a row, third value is a column. So if you want to access this particular location, 0 is representing a layer number, 2 representing a row number, this 1 representing a column number. This is the way we can declare and also access the things. And again, this is a compact declaration, this is verbose declaration. Then comes a very important topic and a very interesting topic in System Verilog, that is dynamic arrays. In dynamic arrays, as the name says, size is dynamic. The arrays what we seen so far will be allocating or come up with a static size. Dynamic arrays in the sense will be not allocating the size when we are declaring that. This is the syntax. First we will be writing the data type, then the array name, and just we will be writing a empty square braces. This indicates a dynamic array. The data type can be any data type, and array name can be any name. Anyhow, we are going to specify with alphabets. Then a empty braces indicating dynamic array. You can look at the declaration first. Bit 7 down to 0, D array 1 of empty braces. This empty braces indicating we don't know the number of elements we have. It is unknown. But each and every location can take 7 down to 0, that is 8 bits. Then we have int type D array of 2. Again the size is unknown, but it will take 32-bit values by default. That is how we can declare the dynamic arrays. And when it comes to the usage, when we are using it, we need to call the new function, then we need to allocate the size dynamically. You can see this D array 1 is declared here, and while allocating the size, D array 1 is equal to new of 4. This new of 4 calling the new function that will be a standard function in System Verilog that will allocate a memory for 4 elements dynamically. Similarly, D array 2 will take integer type, and I am assigning 6 elements to that. And while initialization are assigning values in the same way how we have a packed array or unpacked array assignment, here also for the dynamic array we can use the same method. You can see for each D array of 2 of j, D array 2 of j is equal to j. We can assign a j values where each and every case it will be incrementing, and it will go until it reaches the depth. And also we can change the size of the dynamic array. You can see in the example, D array 1 what we have declared here will be allocated with the value 4. If we want to change the size, then again we can call the new function like this. We have D array 1 new of 10. What this will do, this will remove all the 4 elements what we have, and freshly it will allocate 10 new memory locations, and old values get deleted. That is what we need to know here. If we again call a new function for a particular array, it will allocate new elements and the old values will be get deleted. Suppose if we want to keep the old values also, and we need to assign new extra elements to that particular array, then we need to go for the new method with specifying the name of the array within the braces after the new size. New 10, here you can see new 10, and then D array 1. It keeps the old values of the D array as well, and the retained values will be extended with the current array with extra 4 elements. And also we have special functionalities here with the dynamic array. We can get the size, we can delete the array, we can create the memory using these methods. You can see here is the example. If you want to print the elements, you can use similar $display and for each to go with each and every location, and it will print. If you take array.size, it will print the size of the array. If it is 5, new of 5 we have assigned here. So array.size should give 5 as a value. Here we have resizing it by protecting the previous values as well to 8. Now array of dot size will give us the value 8. And also you can see array will be assigned with new of 6. Now this is a new 6 element assignment, but previous elements get discarded or deleted. So again we can put print a size. And also we'll be having array dot delete. This dot delete functionality will delete the array what we have created previously. This is about dynamic arrays in System Verilog. Then we have associative arrays. Associative arrays are extensive version of dynamic arrays, we can say. So associative array stores the data or entries in a sprays matrix. It is like, you can see, this is the representation. Data type is there. Then we have array name. Then within the braces we need to provide the index type what we are going to have. It is not a size we are going to represent over here. Size will not be allocated in the associative array. As soon as we use it, it will create the elements by its own. But within the braces, we need to provide what is the index we are going to use. In the previous case, we have by default integer type for a size of the array. If you see, while assigning the size, we will be using new and we will be giving the integer type over here in the dynamic array. But in the associative array, so you can see the declaration over here, int a array 1, and within the square braces we have star. This indicates it will allow all the different types of index type for a associative array. It can be int, it can be a string, it can be a bit or byte, any type. If you want to specify the index with a string, we need to use string over here. If you want to specify any class as an index, you can specify my class over here. Let us look at the examples and see. This is the very first example. Here we have defined a module associative array. Int num underscore cars is the name of the array and the index is string type. So, and also we will be having one more int array 1 here and with a star. So you can see the declaration and the initialization. Num underscore cars is equal to, this is the index and this is the value. So if you see, the index is of string type for a num cars. Num cars is represented with the index type string. So this is the index and this is the value. This is the index, this is the value. This is the index, this is the value. It means, suppose if we analyze this as with 3 elements, the value 2, value 1 and value 3 will be represented with Hyundai is the index for this. To access 1 we will be having Suzuki. To access 3 we will be having Tata. So these are the access pointer values we can say. In dynamic array, this will be a integer type. So 0, 1, 2 will be used. To access these elements, now we can use a string type as well. That is with num cars. So now we have a second example over here. We have a type def enum. Enum types variables are trans, receive and repeater. This is tr type. Now you can see the associative array representation here. So 7 down to 0, bit type, array enum. The type of the index is tr type, that is enum type. Now while assigning the values, array enum of trans is 10, of receive is 20, of repeater is 30. Now it is like the first element will be, it is 10, the next element will be 20, the next element will be 30 like this. And this has a type trans, the index is trans here. This will be receive, this will be repeater, right? These are enum types. Enum type in the sense, trans will take a value 0 by default, this will take value 1 by default, this will take value 2 by default. Enum type can also be used as an index type over here, right? Similarly, our array int will be taking int type as a index. So this we have seen. Now we can see the array int of 5, array int of 10, array int of 7 we are using here. So now suppose if you have 3 locations again, 2, 4, 6 are the values, it will be having indexes like this is 5th element, this is 10th element, this is 7th element, like that. This is not a 5th element, 10th element and 7th element. That's why I said at the starting, associative arrays will be stored in a sprays matrix. It is not like a continuous value or anything like this, but just with the index we can access them. Then we have queues. Q is a special data type in system Verilog, which will work on a principle of FIFO, first in, first out. So the representation of a Q or declaration is like this. Similar to associative or dynamic arrays, we have a data type first, then we have a name, and within the square braces, we need to represent a symbol like this. This represents a Q. Dynamic array will be represented with empty braces. Associative array will be represented with a particular type of the index. Dynamic array will be represented with a dollar symbol like this. Now, if you look at the usage of the Qs, Qs will be having bounded Q and a unbounded Q types. Bounded Q in the sense it will be having a specific size and number of entries, limited. Unbound Q in the sense it will be not having a specific size. It is having unlimited entries. And we can use push and pop instructions over here. Push will be used to put the value into Q. Push will put the value into Q. And again, if you use push, it will be pushed to the next value. And whenever we use pop, the first value what we have added will come out. Push and pop functionality. And also we can use pop front, push back, and pop back as different methods of Q. Now let us see an example for that. We have a module here with a Q representation, int Q of dollar. This representation is a integer type Q, and here we will be having an elements which we are assigning to that Q. Q dot pushback 10, Q dot pushback 20, Q dot pushback 30. Means we will be pushing from the back of the Q. This is the front of the Q. This is back of the Q, we can say. From here we are adding the values one after the other, right? Now after the push we can print the values. Percentage %P is the type specifier for array. It will print all the values present in Q. Suppose if you want to remove any element from the front, if you see here Q dot pop front, this pop front will give us the first element what we have added. And also we can take out the element from the back. Pop back can be used, right? After the push, you can see 10, 20, 30 is allocated first, 10, 20, 30 like this. Pop front we did. Pop front in the sense we have a value 10, we have value 20, we have value 30. If you do pop front, 10 value will come out. You can see after the printing, doing the pop front, we will be having only 20 and 30. Suppose if you do pop back in the sense the last value what we have added will come out, 30 will come out. Then the value remaining is 20. This is how we can use Qs. We can access the Q elements from the front and also from the back. Then we have system Verilog processes. We can control the different processes running in the system Verilog through begin end block and also using fork and join. Fork and join is very important feature. If you want to trigger all the processes running simultaneously, then we can use fork join. Let us get in. Fork join, all processes start simultaneously and it will wait for all the process to get completed to come out of the block. It means if you have process 1, if you have process 2 and process 3 like this, we put it under fork join. And you can see the example, it will give you the clear cut idea. Module, we have a display something dashes here. We have fork and we have join here. Inside that, we have begin end as one process, begin end as other process. So this will start simultaneously. Both the process 1 gets start, process 2 gets start simultaneously. We have a display functions here in process 1. We have 2 display functions in process 2 as well. And also outside I have 1 display and also previously to the process we have 1 more display. When this display is called, we have the printing the dashes here, you can see. And this process and process 2 will start simultaneously. Since the first line of code we have a displays, they are with 0 simulation time. So we will be getting the 2 displays at a time. You can see at 0 simulation time we will be having process 1 started, process 2 started. And after 5 time minute of delay, this line of code executes. But the second process also executing parallelly, but it will be having 20 time minute. So after 5 time minute, this line of code will execute. First process will get finished. And even after that finish, we are not printing this value. Why? Because we have join here. It means this line is pending. After 20 time minutes, this display statement will be executed, process 2 finished. Then only it will come out of the block fork join block, and then it will display the outside fork join, then the lines of code. You can see this. So fork join will be used to start the process, multiple processes simultaneously, and we will come out of this fork join only when the process get completed its execution. We have fork join any. In a fork join, we have to wait for all the process 1, 2, 3 to get completed. Suppose if you write for the same example join any, what happens? Suppose if you have two processes like this, at least one of the process get completed, it will come out of the loop. It will come out of the block of code. So here we will be having a 5 time minute of delay. So here we will be having a 20 time minute of delay. So this process will get completed in 5 time minute. After that, the print statement outside the join any is printing already here. So then after 20 time minutes, the process 2 get completed. So join any will be useful when we need to start the two process simultaneously, but no need to wait for both to be get completed to come out of that block. We have fork join none. Fork join none in the sense we need to use join underscore none in place of join. Here also the process will start simultaneously, but it will not wait for the process to get completed. It will just come out of the fork join none block of code and it will print outside the fork join already here. Then after we will be seeing all these depending on the delays, how the process are going to be executed. So fork join is mainly used for starting the process simultaneously. If you use join, it will wait for all the process to get completed. If you use join any, at least one process get completed, we can come out. If you use join none, no process should get completed, we can come out of the block. The difference between begin end and the fork join is that if you have multiple statements in the begin end, they will execute sequentially one after the other. If you have different statements in the fork join, they will execute parallelly. That is the major difference, and that is why we will be using fork join to start all the process parallelly in.
Bro, ready?
सुपर रेडी। ये देख, क्रेडिट कार्ड, डेबिट कार्ड, लाउंज कार्ड और थोड़ा एक्स्ट्रा कैश।
One go. Then comes System Verilog classes. This is a very important feature of System Verilog which will support the verification. Let us get in. What is a class data type? Class data type is a user defined type. It includes data, it will include functions, it will include tasks to operate on that particular data. We can have a function, we can have a task, we can have data inside. This is like collection of data which will be having set of subroutines, that is subroutines are functions and tasks. Okay. In the class, we will be referred to the data as class properties and function and task as subroutines called methods. So class will be having properties called data and also methods called function and task. Whenever we say class properties, it is referred to class data. Whenever we say class methods, we say function or a task inside a class. This will allow all the OOPS concepts what it has will be supported in System Verilog. It will support all the data types, function, tasks in a single container. And classes allow the objects to be get created and delete dynamically. Since class itself is a dynamic type, and whenever we create it, it will create dynamically and it will be get deleted dynamically. Now let us get in and see how the class methods and the properties can be used with a class and end class keywords. Here is the syntax. Class and then name of the class. Similarly, as we write a module in a Verilog, module and then module name we will write. Here class and then class name we need to write. Then we can write all the class data members or the variables, simply say. Then we can have a function and task inside, then end with a end class. If you look at an example over here, we have class with the name packet. This packet will be having address and data variables inside. And also this packet will be having a function called new. This is a simple example of a class. Now let us look at how this class will be defined. Then we can use that class instance in another block and how that object will be created. Here is class SV class and it has a single property called x, a data x, and we have a method task set and also we have a function int. So this is one method, this is other method. We have one property. Now we will be utilizing this class inside a module. Module is a static component. We can include the dynamic class inside a module, but we can't instantiate a module inside class. That is not allowed. In module test, you can see we have an instance of class here, SV class. We are giving an instance name. We call it as a handle as class 1. Now SV class will be referred as class 1 throughout the module. And you can see here class 1 is equal to new we are doing. This is called as object creation. We are creating this class 1 over here with SV class with a new function. Now the object will be created and a internal memory will be allocated for this. So this will be called as a class creation and we will be having an object of that, right? This is end module. This is a very simple example. We will be utilizing this class inside a module and we will be calling the new function to allocate a memory for that. That becomes a object now. Now we have a class constructor as well. It means in the previous example we have seen for this particular class we have a handle class 1 and here we will be calling the new function which is not at all defined over here. It is a standard function call. It will allocate a memory. But that will be called as a constructor of that particular class. To construct that object we will be using new function, right? So new function will be called as a class constructor. This is a simple function new we can define inside a class, and also we can specific code we can put inside a function. For example, you can see class example 2. It has two properties, bit A and integer B. Now we are defining a function by manually, function new. This new is a constructor of this class. Whenever this class is used inside a module over here, this new function will be called. This function will be executed. Suppose if we don't write the function new inside a class, a default function present in the library will be executed. And in that case, we will be not writing the function inside. If you want, we can write a function new. Whenever we are going to create that object over here, this new function will be called. At that time, if we are assigning any values inside a new function to the data members of the class, the value will be get initialized. You can see integer b is equal to 32-bit h, a, b, c, d is the value we are assigning to b. Now this b will get a default value of a, b, c, d when we are creating that class with a new function. This is just to assign the initial values to the data members of class by calling the new function. That's why we can write a constructor of our own inside a class. If we don't write this constructor, it will just call the new function which is by default in a system Verilog library. Then we need to understand how the class assignment work. A class assignment in the sense, for a one class handle, we can assign other class handle. It will get all the properties and methods of the class 1 to class 2. We have a class transaction and end class. It will be having only one data member inside. There is no methods over here. And inside a module, we are utilizing that transaction class. Transaction with a handle tr1 and tr2. There are two handles now. So what I am doing in the initial begin, I am calling the new function of the constructor of that particular class. This is creating the object of tr1. Now we can utilize tr1 effectively. tr1.data is the access of that particular variable of the class of transaction through tr1. We are assigning the value as 5. It is just like assigning data is equal to 5. Through tr1 we are accessing that. This is next we have a class assignment. Now tr1 will be having data 5. We are assigning the class tr1 object to tr2. Now if you see the diagram here, when we are doing the new function, it will allocate a memory. So this memory will be having a data inside. This tr1 pointing to that. When we do tr2 is equal to tr1, what happens? This tr2 will get the same location of tr1 and all the value present in data is equal to 5 can be accessed with tr2 as well. Suppose if we display like this, tr1.data is printed as 5. tr2.data also will be allocated with value 5. Suppose if we want to assign any value with the second handle, now the class assigned handle tr2.data is equal to 10. If you want to display that, it will be pointing to the same location. tr1 and tr2 will get assigned and the same value 10 will be reflected in both. That is class assignment. One class object can be assigned to other by just doing like this, class 1 is equal to class 2. This will share the same memory space.
Over 60% of flagged content is misclassified by AI. Is it possible to improve accuracy? It's tough. Context keeps shifting and so does the content. Words, images, sometimes both. There's no single trick, just smart design, constant learning and careful evaluation. Want to learn how real systems handle this? Join our Scalar Masterclass on ML system design.
I have 12 emails, 30 messages, and a proposal due by 10. How am I already underwater?
I'm in the same boat.
I'm in an actual boat.
I thought Grammarly just fixed grammar. They make boats now?
It's more of a metaphorical boat. Because I've been using Grammarly's AI for years to keep me high and dry. Try it. Grammarly can look through your writing to make it easier to understand.
Then comes the system Verilog inheritance. We are supposed to use the keyword extend. This inheritance, by the name itself, we can see there is a parent, and when we are creating the child class, all the properties and methods of the parent will be inherited to child. That is what the meaning of inheritance is. Suppose a parent class having variables ABC, child class will get an access to ABC easily. That is what inheritance is. Directly we can go with the example now. This is a red color indication is a parent class. The name itself is parent underscore trans. It has a data. Now we have a function also inside that parent class. Now I am creating a child class over here and I am inheriting the properties of the parent class. How we can do that? Class child underscore trans extends from parent underscore trans. This extend keyword is used over here to get all the properties and methods of the parent class to the child class. Okay, let us see further. Now the child class is created, extended from the parent class. Now we have a function void display underscore c here. Display underscore p is the function of the parent class. This is just having a data, this having id, this having display underscore p, this having display underscore c. Now we are using it in a module. Module class example, initial begin. We have a class instance here, child underscore trans. We are directly instantiating this child class here and we are giving the handle as c underscore tr. Now before accessing the data members, we need to create the memory for that. That is object creation. We are doing through calling new function. Then if you see, c underscore tr is the handle of the child class. Dot data we are accessing. This data is a property of a parent. We can access through the child now. The meaning of this line is that c.tr is the handle of the child. It has an access to the data of parent. And child class is updating the property of the base class with the value 5. And also with the c._tr handle, we can also update the property of a child as well to 1. If you call the function c_tr dot disp_p, disp_p is the function of a parent. Now this child class accessing the method of the base class, right? And also child class can access the method which is there in the parent class as well as the child class, right? So the terms what we are going to use to represent a parent class is, sometimes we call it as parent class, we call it as base class, we call it as super class. Child class will be called as derived class, subclass and extend class. There are different names we are going to use to represent a parent class and a child class. So here the thing is that if any other class want to inherit the property of a parent class, we need to use a extend keyword, then the child class will be created. Then only it will access all the parent class properties directly from the child class handle. Then we have a super keyword in class. We need to understand when the super keyword is used. Super keyword is used in a child class or in the derived class, which will be referring to the class member of its base class, its parent class. You can see the example here. We have a parent class here. We have a child class. We have data and display as the property and method. Now in the child class, you can see it is extended from the parent. anyhow it will inherit these two inside the child class. It is also having a display. You can see super dot data is equal to 3 we are doing here. You can see super dot data, super dot display. What this super keyword is doing here means we have a data, okay, we have a data inside a child, but through the super keyword, you can see through the super keyword, we are accessing the data here. This data corresponds to the parent class data, not the child class data now. Through the super keyword, if we access, anyhow this data is accessible in the child. Through the super directly we can access the data of the parent class. Now this data what we have here is not accessing the child class data. And also we have a display. You can see inside a function display itself we are calling super.display. This keyword display, because of super, it is calling the function display of the parent class. Okay, so the meaning is that if you use a super keyword, that will refer to the parent class properties and the object, not the child class properties and objects. In the child class we are accessing the parent class objects with the same name we have, but super keyword allows us to use only the parent class properties and objects. That is what the meaning is. Similarly, here we have a instance of a child class inside a module. We are creating an object for that. We are accessing the data and also display. Since we are accessing through the child class handle data is also present in the child class. Without using a super over here, it should access the data of the child class, but because of super, what happens? It will access the parent class properties and the methods. So whenever we use super, it refers to the super class. It means the next base class what we have for this child. We have this keyword in class. You need to understand this also. Suppose if you have a representation called data, variable data, and inside a function again I have an internal declaration called data. We have declared the same name. So this data is a variable which is declared inside a class. This data is a variable which is declared as input or output inside a function. Whenever we call this function new, this new function will be allocated with some values. Here first one is the data, second one is ID. 5 will come as the data now. This ID becomes 1. And we want to pass this information to the variable of the class. How we will be doing that inside a function means whatever data we got through the function call will be assigned to this data as this dot data is equal to data. So here the data what we have as a internal variable of the function is this. We are assigning that to the class property through this function, this keyword. This keyword says whenever we use a variable data through this, it is representing a property of that particular class. This dot ID corresponds to the class property. This ID corresponds to the function property. This data corresponds to the function property. This is the way we can access the data or ID of the transaction class using this keyword. Whenever you use this keyword, that corresponds to the members of the properties of the class, not the function or a task. Then we have another concept of polymorphism. So far we have seen inheritance. Inheritance in the sense getting all the properties of the parent class to the child class. Child class can access them easily. And we have seen super keyword. Super keyword can be used in a child class to access the parent class directly. Even with the same name, we have a child class declaration. Now comes the polymorphism. The name of the polymorphism says different forms or the different ways of accessing. So in the system Verilog, we can write a base class and a derived class extending from the base class like this. Suppose if a function, my function is written in the base class, my function is written in the child class as well. It means what? The same name we have used in a parent class and also in a child class. Okay. When we are accessing through the child class, this might be called. But when we declared it as virtual, you can see the function, my function will be declared it as virtual. But child also having the same name function, but it is not declared it as virtual, that is just a function. In this case, what happens? Now, parent will be having a property called A, child will also be having a property called A. Now, parent is declared it as virtual function A, child will be having just A. Now, whenever we call this A, this child class method will be get called. since it is a virtually. This is virtual function. This is not called. That is what the meaning of polymorphism. It says, suppose if you have a same function with the same name, since it is declared as virtual, this will get a least priority and this function will be get called. You can see the example now. We have a base class instance, we have a derived class instance, both in a module, and we are creating the object for both. Now we are trying to access my function from the B pointer. B in the sense it is an object of the base class, but still it will call the base class my function itself. And now we are assigning B is equal to D. Now the derived class will get all the assignment to the base class handle. Now if we call B dot my function, it will call the derived class function. It is not calling, even after the assignment, it is not calling the base class function. Why? Because it is represented as virtual. That is the example for polymorphism here. Even with the same function name we have and also an assignment, still it is pointing to the derived class. It is not calling the function which is represented in the base class, since it is represented as virtual. Then let us see virtual class. Class itself can be represented as a virtual now. In System Verilog, this virtual class, if we define, it is known as an abstract class. Abstract class in the sense it is an example class, we can say. This virtual class cannot be instantiated anywhere. It cannot be instantiated anywhere means we can't use it directly inside a module, right? You can see this example, it is an error case where virtual class base class. Now we are trying to use it inside a module, and also we are trying to create a object for that, and we are trying to display some function, display some value. But it will throw an error since you are accessing or instantiating a abstract class. This is not allowed. So how we need to use the virtual class then? Suppose any class declared as a virtual, this part of the code can be used through extending it from the child. You can see here we have a class child class. We are extending from the base class. So this class can be used as a parent, but we can't use directly. That's why child class is created now. We have a data over here, assignment inside a function new, and we have a child instance here. We can utilize a child instance which is created from the base class, base virtual class. Now virtual class is not directly using here. Now child is equal to new. We are printing the display with child.data. So you can see we have an assignment of data that is part of the virtual class, base class. This data what we are assigning here is the parent class data, not the child class property. We have no declaration of data here, right? But because of the extension, we got an access to the data of the parent class, and now we are calling the we are printing the child.display. This will display the value of a virtual base class. Here the meaning is that when we declare a class as virtual, we can't use it directly. We can create a child class from that and we can use it. Then also we have a pure virtual function inside a pure class. Here pure virtual function can be defined like this inside a virtual class. Here what happens? This virtual method inside a abstract class can be declared with a keyword called pure. It becomes pure virtual method. It is just a name of the function we have declared over here as get data. It will return int type, but the definition is not there here. Means we'll be having only the declaration. The definition we'll be writing when we are creating a child class. That is what pure virtual function, which is declared inside a abstract class like this, or a virtual class. The meaning is that we can declare pure virtual function inside a virtual class that will be not having any functionality written inside. We can return that functionality when we are using inside a child class.
Hey, still thinking about joining the 30-day Python using AI bootcamp by AI for Techies? So what if in 30 days you could go from knowing...
Then comes System Verilog randomization. Randomization is very, very important in System Verilog while writing the test benches. To generate the stimulus, we can just do randomize. So all the data variables what we have, all the properties of the class get randomized. Let us see. What is randomization? System Verilog randomization is a process of generating the random values to a variable. In Verilog, we have seen $random, we have seen $u random. Random will generate the integer values of a signed type. $u random is generating the integer values of unsigned type in Verilog. But in System Verilog, we have a functionality called randomize. This randomize function is a default function. This will allow us to randomize a particular property of a class. Let us see. We need to represent a property of a class or a data member using keyword rand in the time of declaring inside a class. We can randomize a complete object whichever the variables declared as a rand. And also we can declare that data as randc. The difference between representing it as rand and randc is that this address is a bit type. It has a 4-bit representation. It will take all the values from 0 to 15 randomly. But if you use randc, what happens? Data get randomized. So this will take a value of 0 to 15. If you represent it as randc, what the time of randomization, until from 0 to 15 it get completed, the random values will not be repeated. Means randc is like randomized cyclic. Means random cyclic in the sense all the values should get randomized between 0 to 15 get completed, then only the repetition values will come, and again until it completes that set of values it can generate, it will not get repeated. Here in the rand, we may get repeated values as well. You can see the example. We have value 1 and value 2 represented as int, and one is with rand, another one is with randc. So we can call a randomize function in this way. Inside a task, I have this dot randomize. I am just using inside a if. Don't worry about that. If this randomize get executed, it says the condition satisfied, and it will display these two. So this dot randomize is a function we are calling here. This do the randomization of value 1 and value 2. So this keyword will be representing this class properties. That's why this dot randomize will randomize value 1 as well as value 2. And if you print the values of the randomization, you can observe because of the value 1 is represented as rand, it may get repeated values when we do the randomization. And because of randc, this value 2 will not get the repeated values until all the set of values of that value 2 get completed. And the thing is that here we can use this randomize function to randomize these two values in System Verilog. Okay, you can see we are calling that random example over here, and also we'll be calling the function that is run, right? So this will allow us to do the randomization inside a module by calling this particular task of a random example class. Then for that randomization, we should have a control. Suppose if we want to restrict this value 1 should be in the range 0 to 10. In such case, we can use a constraint to control the randomization for this particular variable. Now let us see constraints in randomization. So we will be using this randomization in a test bench to generate the different random stimulus. It is like we will be having a reset. That reset should be 1 throughout the simulation. Our reset should be 0 throughout the simulation. Or the value what we have that should be less than or equal to 10, or it should be greater than or equal to 10 or 50, like that. In such cases, we can use a constraint. We can put a constraint on randomization. How we are going to write that? We need to use a keyword constraint. We should give a name of the constraint. Then within the flower braces, we need to write what condition it is. For example, constraint, range constraint is the name. Within the flower braces, you can see I am putting a constraint for a value that it should be greater than or equal to 10. Means the values should be generated as random values. Those should be greater than 10. 0 to 9 it should not generate. Similarly, I have another constraint inside. Value should be less than or equal to 50. Means we are telling the randomizer that it should generate only the values between 10 to 50. It should not be less than this. It should not be greater than this. That is the way we can put a constraint for the randomization. Similarly, set constraint value inside 10, 20, 30, 40, 50. Only use these values and do the randomization. then value 1 should be greater than value 2 always when you are going to randomize. This is what constraints in randomization. You can see the example. Again, the same example, value 1 and value 2. Previously, we have not used this constraint. We just use the randomize function to get randomized. If you use this now, this constraint, the value 1 while randomizing, it will take only these values. Value 2, always it will be greater than 1. And value 2 will always be less than or equal to 10. This is the constraint we are writing for value 1 and value 2. And we will be calling the randomize function. And once we call this randomize, it will go and look for the constraint what we have written. And also it will adjust the randomized values within this particular range or the condition what we are going to write in a constraint. And again, this function, the randomize and display, we are calling inside a module over here. You can see randomize and display through an example handle of this particular object. Then the different types of constraints we need to see. We have a very useful constraint called inline constraints. These inline constraints will be written at the time of using a randomize keyword. If you see the previous example, here we are using a randomize function. With this randomize function, here directly we can put this constraint that is called as inline constraint. So item is an object handle here. Dot randomize is the function we are calling. We are writing with this condition you randomize. Means value 1 should be greater than 150, value 1 should be less than 160. Similarly, with randomize with value 2 should be inside this range. This is inline constraint. We are writing the constraint in a line of a randomize function line itself. Then we have another type of constraint which is a soft constraint. Means inside a class while declaring the properties, we will be writing the constraints for them. This is a general method. Or we can write a constraint inside with the randomize function as well. That is inline constraint. The soft constraint is that here in a randomization, the one more rule is that this is a class, it has a value, and we have written some constraint for that. Suppose while doing the randomization, if I use a inline constraint like this, you can see this is an inline constraint. Suppose if you don't write it as soft, what happens? There is a conflict between this constraint and this constraint. There should not be a conflict in a randomization. Otherwise, your randomization will fail. So to have a constraint written over here inside a class, and also we will be having a inline constraint, what we need to do? There should not be a conflict. If a conflict occurs, if it is written as soft, this constraint will be discarded or neglected, and only the inline constraint will be executed. Why it will be written as soft means, suppose if you don't write soft, we are telling the randomizer or the simulator that stick to this rule while randomizing the value. And again you want a facility that I need to change that randomization constraint in an inline while doing the randomization with a line. So now you will be adding the function here and value constraint here. Now it will look for this constraint and also this constraint. It will get confused and throw you error. To avoid that, we can keep this as a constraint as a soft constraint. Then whatever you use at the time of randomize function call, that constraint will be called. You can see here we have a constraint for the value like it should be less than 5, 10 to 15 like that. It should be 5 or in between 10 to 15. Randomize function here